So, when it comes to legislation of emissions in the maritime sector, we learned that scrubbers played a major role to reach IMO targets on limitation of SOx emissions.
That's true, and after January 1st, 2020, there was a boom in the scrubber industry. And for today, around 4,500 ships equipped with scrubbers sailing on the ocean. And of course, also here, sensors are playing a major role to prove the efficiency of these scrubbers. And now we have the great pleasure to have Don Gregory, Director of the Exhaust Gas Cleaning System Association, here with us. And Don will give us an update and outlook on market regulation and technology. Hi Don, how are you?
Yeah, good morning Henrik, and good morning Ramona. Thank you very much for inviting me this morning. I'm actually sitting in London today at the London International Shipping Week. So this topic is very topical at this shipping week, particularly with carbon capture as well.
So you're very busy, especially with these topics, of course. Don, we make it short so that you can go to the next conference. What roles scrubber have been played in reaching IMO goals for desulfurization?
Well, I think the truth of the matter is that without the scrubbers and the CE Delft report that was commissioned by the IMO MEPC organization around about 2018, we'd still be probably using high sulfur fuel at sea today. But it was because they reckoned that there would be an estimated 5,000 ships that would convert to scrubbers that the administrations at IMO decided that 2020 was a date that could meet the requirements to have fuel available, because there was a big worry there would not be enough fuel available. But thanks to scrubbers and technology, that's been solved.
Yeah, that's true. And what is the experience in terms of reliability and sustainability after now some years of experience?
Yeah, well, we've had scrubbers in the market since 2014, really, because their first scrubbers were installed on ships operating within the European ECA, and they gave very good performance and gave very short payback periods, so the economics of running a scrubber with high sulfur fuel at a lower operating cost was quite significant. Then globally in 2019, there was a big uptake for international ships to use scrubbers, and these are of course monitored by port state control and flag state control by the systems that are used to monitor the performance of these scrubbers. So not only have the scrubbers been reliable, but the flag states, the administrations have been able to look at the data that's recorded on board the ship and show that these systems have been operating throughout the period reliably and providing very low emissions of sulfur, often lower than the prescribed limits.
Yeah, that's true. And now the latest studies has indicated that scrubbers have a lower well-to-wake CO2 footprint than lower sulfur fuels. And further, there are first carbon capture storage pilot projects, like this project in Japan, for example, based on the scrubbing process. Has a scrubber also, let me say, a future in terms of greenhouse gas reduction? What is your opinion here?
Yeah, I mean, I think that's one of the unsung stories about exhaust gas cleaning systems. There's been a few people who've detracted against them and said that it's just a transfer of pollution. All the data would suggest that that's not the case. A recent CE Delft study claims between 10 and 20% well-to-wake reduction in CO2, simply by the fact that less energy is used in the production of the high sulfur fuel, which then produces energy to drive the ship along. And an earlier study by Konkawi considered up to 20% reduction in a well-to-wake. And then really back in the days, and now we're talking back in the early 2020s, the study done by the Secretary General's team on fuel sulfur also indicated something in the region of about 14% reduction in CO2, taking everything into account, taking into the fact there's pumps that are required on board ship. So this is a real here and now contribution to reducing CO2. But of course, that's not the only problem. We've got to reduce CO2 by quite some considerable amounts. And, there's targets being set by UK governments and others that are quite stretching. And EGSA members are out there now developing technologies which absorb the carbon dioxide in the exhaust gases, and are looking at how that can be stored on board before it's taken ashore and possibly recycled into another fuel that comes back on board again.
I think there are very promising first pilots running already, and that development never stops. Don, we talk about scrubbers in general now. What role playing sensors in the ecosystem scrubber?
Well, it's very interesting that scrubbers and the scrubber guidelines are quite unique in the IMO ecosystem for approval of technologies. This is the first time a technology has been required to demonstrate its performance day in, day out, minute by minute, and record that. And without sensors, that wouldn't have been possible. Otherwise, we had a black box, and we would hope that it's actually taking out the sulfur. But by using gas sensors and recording the concentration of SO2 in the gas after the scrubber, we can demonstrate that the scrubber has reduced the SO2 level below that of the prescribed fuel. And likewise, for the water that's being discharged overboard, we must make sure that the marine environment is protected. And again, sensors have played a vital part. Effective and simple to operate. Those are key, and they've done their job very well. Thanks.
Yeah. Okay. Thank you, Don. Finally, what is your assumption of use for scrubber in the future? So what is your forecast of this technology?
Okay, well, the EGSA members struggled in 2019 to keep up with the demand. Everybody waited to the last minute, and then suddenly there was a massive demand. And, that 4,500 number that you mentioned earlier, many of those were delivered within a sort of 12-month period. It was quite busy at the end of 2019 and during 2020. This year, 2021, orders have subdued somewhat, but nevertheless, there's a steady flow of orders coming from new buildings, particularly the container ships, the very big container ships and the bulk carriers. They all pretty much having scrubbers as standard. There has been concerns that you're aware of as well, Henrik, of possible harm from open loop scrubbers. Well, EGCSA has run an ecotoxicity study and will run further, and those studies have confirmed there's no aquatic impact from that. I think going forward, as to answer your question specifically, fuel prices are going to encourage more purchases of scrubbers. And in fact, some of the companies that have gone for LNG are now kind of regressing it because the cost of natural gas is just shooting up at the moment. There is a big attraction to maintain compliance, be environmentally friendly, and install scrubbers. And as you say, there's more developments to be had, taking out black carbon, particulate matter, and of course, carbon dioxide from scrubbers. So I think just like in the tailpipe of a motor car, scrubbers are here for the future.
Thank you, Don. Yeah, and I think further development of the scrubber brings additional functionalities and add values, so both for the environmental and for the owner. Thank you, Don, for your contribution. It was a pleasure to have you here on our conference.
Okay, you're welcome. Thank you very much for inviting me.
So we've just heard it from Don. Scrubbers have played a major role in the shipping and will play a major role in the future. And new add-ons like carbon capture and storage or PM or NOx reduction technologies will be integrated. And I think these new functionalities make scrubbers even more attractive also in the future.
And the continuous emission monitoring system is a key module in the scrubber ecosystem. Regarding this, we warmly welcome Christian Lohne. He gives us the latest update and will present the brand new MARSIC 280 for the very first time today. So followed by him, there will be an interview with Ole Christian Drablos from Wärtsilä, and we will get a good overview about this topic. So, hello Christian, and the stage is yours. I hand over to Reute.
Hello Ramona, hello Henrik, thank you very much. It's a big pleasure for me to participate in that conference, and now get started. So first of all, a very warm welcome from our video stage here in Reute. My name is Christian Lohner, and I'm working as a product manager maritime in our global business center Analyzers. In total, I'm working 13 years for SICK, and in 2018, I took over the role as a responsible product manager for the MARSIC. And in this role, I would like to give you some more information about emission measurement, why this is mandatory, and I would start with a more general approach first. So Don and Hindrich discussed what it means for shipping, what was the journey there, but I would like to start in a different way. And for that, we have prepared a short video giving you some visual impression on that, and I will comment. So please start the video. So we have a modern world. In our modern world, we need energy. We generate waste. And for that causes emission. We need emissions caused by power plants. We have waste incineration plants that cause emissions. So emissions are there. So we cannot change it from one day to the other. So what can we do? We can only measure and control them at the current point of view. And this is not something new in land-based applications. It's a state-of-the-art technology which is used for many years. And that is also a strength of SICK. So SICK is one of the leading suppliers supplying analyzer solution for land-based emission measurement. And here you also see some impressions from our production plant in Überlingen, where we produce in a professional production analyzers with a high quality standard. And with that, it was just a matter of time when these requirements from a land-based solution have been transferred to the maritime industry because vessels have a huge impact. We're all aware of that vessels causes emission. And in 2005, MARPOL Onyx 6 was approved, showing the significant change of desulfurization in 2020. And SICK took this as a chance. So we have that know-how as a sensor supplier or analyzer supplier to contribute and also to enable a green combustion. And with that, in 2008, we participated in a development project. We put a land-based analyzer on a vessel. We combined that with the requirements which we have on board, put it in a new development, and launched our MARSIC series in 2014. And then we really can say a success story started. Our type-approved analyzers have developed to the most accepted solution in the market and are used in a different kind of vessels. So they can measure, for example, NOx values, what we have due to the MARPOL, and also they can be used in combination with a scrubber to measuring SOx values before and after scrubber. And when you are in a vessel where it has a scrubber installed, many times you see a MARSIC installed. And here you see from marine traffic our running fleet. So we have more than 1,500 vessels running with a MARSIC installed. So there we can be really proud on that. So what I would like to show with that, it's a kind of journey what we did. So right now we have a current status quo in maritime. So that took a long time to bring it to that. So what we had, there was no solution ready. So it was a journey which the experts had to do together. So we had the sensor supplier SICK, and we had a scrubber manufacturer. We did it together. We developed the right product. We brought it to the market, and then a really good solution started. But that's now only a status quo. As Don and Hindrich mentioned, scrubbers have an opportunity, and further things will happen with scrubbers. And that it's also something which we have to monitor, and we really believe in that a scrubber can contribute for decarbonization in shipping, also to reduce greenhouse gases. And that is something where we also can help. And to give you a further insight in that topic, I do not only want to join my opinion on that. In advance of the conference, I had the chance to speak to Ole Christian Dablos, who is Director Supply Chain Management, Exhaust Gas Treatment Systems at Wärtsilä. And we both had some time to have a review how scrubbers have been implemented, which kind of analyzers we have. And we spoke about the current status regarding scrubbers. And we also had a short discussion regarding the outlook and how we can do. So please have a look into the interview video. Hello, Ole Christian. So thank you very much for your time and your participation for our Virtual Sensor Ocean Conference.
Thank you much for having me. It's a pleasure to be here.
Today, I would like to use the chance to talk with you regarding greenhouse gas emission and which role the maritime industry has regarding the greenhouse gas emission. So 2020 was a very significant year for the maritime industry. So the global sulfur cut come into charge, and shipping has or was forced to change fuels to low sulfur fuels or use exhaust gas cleaning systems, so-called scrubbers. So you as Wärtsilä, you as a market leaders for SOx scrubbers, and the first wave in 2018, 2019 for scrubbers was very high. So what have been your success factors and what is important for a successful and reliable scrubber installation?
Yeah, the first wave for scrubber installation was indeed very large, Christian. Having a supplier base where the partnership approach is in focus in combination with a scalable supply chain capable of meeting the market demand has been and still is an important success factor in securing high quality scrubber systems. As a global service organization, we're committed to providing lifecycle solutions for the international shipping fleet to tackle pollutants into the future.
Yeah, cooperation, it's really a good point on that. And I think that was for during the installation, what we had it all, let's say for delivery. So, but just another question is before the global sulfur cut, so many cruise liners have installed scrubbers. So shortly before the global sulfur cut became in charge, also tankers, containers and bulkers also changed it and also installed scrubbers. So from your point of view, is there any difference between these vessel types and what are you challenging also regarding the SEMS? Because if the SEMS is one key system of a scrubber and if the SEMS does not work, the crew or the ship owner is not allowed to use the scrubber.
Yeah, cruise liners have been early adopters thanks to the routes they travel and of course the brand and perception reasons to be clean. The Avian scrubbers is a well understood sulfur cap compliance solution. So we see how ship owners and operators still choose modular scrubber solutions for their new builds. And we also notice a slight increase in the interest in retrofits. In short, the market seems to be on a rebound in this area. When we first started with scrubber solutions more than a decade ago, there did not exist any SEMS designed for marine use. We started out scanning the market and installed several systems in parallel in an R&D facility and ran them with marine setup for years. The first units of SIC analyzers were performing promising in these tests, but they're quite large units designed for land-based use. It was when we agreed on the design of the MARSIC units and these were launched that we finally got a system that met our most important criteria, such as durability, footprint, and easy maintenance and installation.
Yes, so it's a really good example, and I think that's a success story for both of us. You have developed a scrubber, and we developed a SEMS system for that, and now we have a really nice package together with this collaboration we had. But just looking forward, do you think that scrubbers will only be limited to SOx application, or do you see there further applications for scrubbers to contribute to a carbon neutral shipping?
There is no single solution to shipping's decarbonization journey, which is why it's right that we think about how carbon capture and storage, for example, could be used on vessels in tandem with other solutions. If we can create an ecosystem of modular technologies around the stack to tackle pollutants, we will be playing our part.
Yeah, so I think that's a really good summary what you did. So there is not one solution, it will be, let's say, modular things and doing step by step and adjusting to the different kind of vessels. And for this modular system, I think also different kind of analyzers or different kind of tasks have to be done. And if you just look on what we do with our cooperation, how can a good cooperation with a SEMS supplier support to reach these greenhouse gas emission targets?
Our services are highly dependent on the support and product quality we get from our suppliers. MARSIC is a great example of a partnership that focuses on these elements and supports the overall sustainability of shipping.
Thank you very much. So that was a very nice to talk to you, very interesting. So thank you very much again for your time and looking forward and to see you next time. Oh, yeah, you're always welcome. So thank you. Have a good day.
All right. Thank you.
Bye-bye.
Bye-bye.
Yes, that was my interview with Ole Christian Dablos. So thank you very much again for his time to joining me for having this interview together for our conference. So these have been just a few takeouts. We had a very long discussion and a very good discussion, and let's say we had an overview about the whole story. It was really a journey. There was no analyzer. We did it. There was a collaboration bringing the experts together, and at the end, we developed a good solution which is now working. but this is not the end. The journey will continue. So we have a status quo, which we still which we use, and we all believe in the SOx scrubber business, and that's also what we are going to do. But there are further options, which I will come later back at the end of my presentation. But before, I would like to focus on this SOx scrubber application, and we also want to prepare ourselves. So we have a portfolio. We have two analyzers in charge. So we have a hot wet system with the MARSX 300, and we have a cold dry system with the MARSX 200. What we saw, MARSX 300 is running perfectly. It's according to the relevant application. So we do not have to do anything, and we're prepared for the second wave. With the MARSX 200, we saw it was a little bit over-engineered. We wanted to fulfill too many applications, and we saw for this pure SOx scrubber application, we do not need so much, and we had to do something, and we decided to do something. We now redesigned it, and that is what I would like to present you today, our new MARSX 280 analyzer. And before I show you the analyzer, we have a short teaser, so please start the video. So that's it. It's not only an animation, it's a real product, and that's I will show you today. So what we did, that's our new MARSX 280 analyzer, maritime emission monitoring system for pure DSOx applications, or measuring after a SOx scrubber. What we used for the product, we used our analyzer, which we used already for the MARSX 200, which is well proven, also field experience, so it's working. And what we modified and have optimized is we call it sample conditioning device. So in this unit, we combined a gas cooler, new sampling gas pump, new electronic components, and so on, according to the latest state-of-the-art technology. We could design it really compact. We put it in this cabinet, and just to enable, and one of the, let's say, do some optimizations regarding the MARSX 200 is we put the two cabinets already we pre-mount them on a mounting frame, and what we already do in our factory, we do the pre-wiring between the two cabinets. So the installation on board will be much easier than compared to the old version of the MARSX 200. So this can be seen, even if there are two cabinets, it can be seen as one cabinet. You just have connected to the heated sampling line, the bundle of pipes, and the SFU, which is similar to the MARSX 300, and you need power connection Ethernet, and then the analyzer is working. So that's a huge optimization, and that's what we're going to see. And last but not least, this week we also got the signed type approval from DNV. So also now this analyzer has a DNV type approval, which we are now proud of. And with this type approval, we go in the next step. We also approach other class societies to get further type approvals in the future. Unfortunately, due to the time, I cannot give you much more details, but if you want to have more details, please visit our website or get in contact with SICK directly, and then we will give you further information. So time is running fast, and I hope this my presentation was interesting to you. We heard many things, so it was really a journey, and this journey is not over. And what this journey also requires is collaboration. So, and I want to give you the right feeling. So SICK is the right partner. So if there are new requirements for maritime emission monitoring, SICK is the right partner. We have the land-based knowledge, we transferred it to the maritime world. There we really established a product which is has developed to one of the most used systems in the maritime industry. And yeah, now we look forward to the future. Second scrubber wave will come for SOx scrubbers, but what will be next? So journey is not ended. We will continue and we want to be part of that. So we want to be your partner. So far from my side, thank you very much for your attention. And now back to you, Hendrik and Ramona.
Wow, Christian, thank you very much, and good to see that SICK invest in new analyzers and complete here the portfolio. And good to see that Wärtsilä, as a major key player in the scrubber business, rely here on SICK, sensor technology. And congratulations to the first type approval for the new MARSIC 280. We have some questions in the chat. The first, and here I can prove you again, how many SICK installation we have?
It's something where we're really proud of, and you saw it also in the map from marine traffic. So we have a running fleet of more than 1,500 vessels. It goes up to 1,500, 1,800. So there we can be really proud, and I think there we have a huge market share in scrubber applications.
Great, that was the right answer. Then the next question, your solutions are extractive gas analyzer solution. Why don't you offer in situ analyzer mounted directly to the stack? Is it cost attractive and require less space? What is your answer on that here?
Yes, I would say I would go back to answer it in a more general way. So because what I told you at the beginning, SICK is a leading analyzer for manufacturer for analyzer solutions. So we have the different technologies in our house. And when we decided in 2008 to go to a vessel and saw it with all the requirements what we have, in situ might be attractive due to cost and let's say a quick measurement and so on, but with the things you have to do additionally and also what we have on a vessel. So it's a big piece of steel. We have movements and the in situ has to be adjusted very correctly. And if we have movements in the steel, measuring does not work. Maybe also we have effects we are working in a environment with huge humidity and particles, so that will not work. And due to that, from our opinion, we decided in 2008 not to go with in situ. Also for calibration, you have to take it out and take it to a spot. And we said extractive is a more feasible solution for this maritime emission monitoring.